everyone. Welcome to our session. This is Building Multi-Agent Systems with AGNTCY. And AGNTCY is an open source collective, and we're going to talk to you about how you could build agents and multiple agents to accomplish a task. So,
yeah, before we get into it, can I just get a raise of hand? Has anyone here built agents before? Yeah? Has anyone built like an MCP server, an MCP client?
Yep,
all right,
so we got a
cool.
couple of yeses in there. Okay. All right, we are not the typical DevNet developers in here. We're part of Outshift. Outshift is our incubation group. My name's John Perello. I'm a principal engineer. Worked on a lot of different Cisco applications, and in our incubation group, we are taking things that we see is going to be the future of technology for Cisco. We're doing quantum computing and Internet of Agents as our two major focuses. This is what we've been coming out with, is trying to come up with an open source way of building agents. So we're going to go over that, tell you what AGNTCY is, what the different areas are, and how to build multiple agents out of the framework that we're proposing. We are by no means done. Usually in DevNet, you get developer advocates that come in and say, okay, here's the solution, we've already got it, try to use it and go work with it. We're like, this is the first step, and there are things that are going to be coming along, and it's been changing like so quickly, like almost week after week it's been changing, and even today there was stuff released today that we're like, holy cow, there's new stuff. So every day there are new things coming out, but we're trying to organize this stuff in the open source movement. So that's me, and then Cody.
Yeah, I'm Cody Hartsook. I'm a senior software engineer, so I'm a practitioner in this space. So last 3 years or so, 2022, 23, started building AI applications, Gen AI specific applications. I've kind of seen the growth of going from a simple RAG application, how do you talk to your documents? We've probably all seen examples of that, to then now we're building agents with tools. How do we interact with an environment? How do we interact with external APIs and systems? So we've been through that journey, and this work kind of reflects our process in the last few years.
Cool. Okay, so you guys all know the drill. You're probably hearing us already because you're on the mobile app and all that. So step one, good. If you can hear us, great. So you've got that. If you've got questions and stuff, you can ask in the WebEx channel, as you know from the different sessions. We'll be answering them. Since we're both here, we'll probably answer them after. If there's a few of our teammates, they'll be answering them as they can. What we're going to do today is we're going to go over what multi-agent software is, just to show you kind of examples of what things that people are building right now. People are building one agent or just trying to get one LLM to do something. What do we see as Cisco as we see multiple agents starting to expand? So again, if you could roll back the clock to something like the year 2000, everybody's building web server. I'm building a web server, look what I did. What happens when you have thousands of them or tens of thousands of them? That's what we're trying to do. We're trying to see what happens when we have multiples of these, okay? So we'll go over that. We'll go over what the open source collective is. We're going to show you a reference application. So that's going to be the sock shop. If you guys are familiar with that, Kubernetes for agent development, that's something you guys can take a look at. And then we're going to go over the components that we've put out there and started to deliver just for the first shot at this, but by no means are we going to be done. The industry is going to be changing. And then we'll give you some things that you can try out for yourself and how you can go join the consortium, okay? Now, feel free to ask questions, okay? Because we're putting these things out there, but we know that everybody's been working on this and that there's a lot of changes going on. So if you see something, just ask. You can go to the mic and ask, or you can just shout it out, and if I hear you, I'll just repeat it for everybody else so they can hear it in the headphones, okay? Okay, multi-agent software, we're going to start there. What is multi-agent software? An agent is, by the definition that we're using, is an LLM that is composed inside software to do a specific task. So I can get an LLM that we kind of wrap in an object so that we can say it does some task. So I could have one that does just say financial forecasting. I take an LLM that might be trained on specific areas, like financial areas, and I could wrap it up into an agent that can do financial calculations.
And just to add in there quickly, the power that we have too within an agent is taking this reasoner that we have. LLMs are great at taking in text, being able to reason about it, being able to parse it. What we're doing in an agent is being able to give it context of its environment. So now it can reason on things, but we also want it to be able to take action. So whether that's calling a tool for a specific service, like you said, financial data, giving that reasoner ability to kind of impact its environment. with context.
So a simple agent might be you have an LLM and you have some tools that are local to it. But what started to happen very recently is there's a thing called an MCP server, which is a server that has some tools on the other side of it. And what that means is it makes it easy to add tools to that model. So basically when you have a model and an LLM that has context, that context is going to be coming from some other source, and MCP is a way to organize it. To say, hey, can we go and get something from somewhere? So we've been building systems that do some of our SRE work. An example of a MCP server might be a server that stands in front of GitHub so that you can do Git actions on that. Or it might be something that stands on the front of your HR system that tells you who's employed and who had a review or something.
Thousand Eyes.
Thousand Eyes, there you go, Thousand Eyes. Talk more about that one, yeah.
Yeah, so then the next kind of logical progression of this is instead of just interacting with another system, another API, a tool, what if we had a whole other agent now that kind of takes that place? And now this reasoning is happening over the network, but you're really reasoning between two different agents that have varying capabilities, but unlike microservices or kind of more traditional services, they're communicating over natural language.
Yeah. So what's the trend right now has been, you have a model, you want to add data to it, you can use MCP as a server to get to it, and other people are like, oh wait, I can turn an agent into a tool inside MCP and just use it that way. And that's okay for some communications, but what we've been thinking about is that agents should work together. One agent should be talking to another agent and maybe negotiating or coming to some consensus. That can't happen with tool calling. So we might have 3 agents that are built like this, they want to communicate across to each other, and they have tools that they're able to work on. Okay, so that's what's going on with multiple agents as we start to build systems. Another way to look at agents are, I might have a simple agent that might want to call out to 3 agents here as a service from some other service. So that could be like Salesforce. So this simple agent wants to talk to Salesforce and get my Salesforce information. I might want to talk to a Workday or an HR system and get employee information. And I may want to talk to a billing application where I'm billing out to somebody. So those things might go through your normal API calls. People are building systems like that now. You'll get your key, you'll do an API call, and you have to know the API. What's going to probably start to happen is you'll get your API key, but then instead of talking through an API, you're going to be sending prompts to an agent and then coming back. So that's the change that we're seeing, and all that communication that's going on, we're going to have to organize that and have the security authentication in that. That's the problem that we're starting to see, okay? All right, any questions there on on that? Okay. All right, so let's talk about the Agency Collective and what we're trying to do. This is the pitch for what Cisco has formed. Cisco has formed an open source consortium of companies, LangChain, Llama Index, the folks at Galileo, Traceloop, they do observability. A whole host of other companies have come in. The vision is that we believe in an open, interoperable network of agents. We want to keep that open. The same thing that happened with web servers when they were all coming up. People were like, hey, I started up a web server, I'm doing HTTP to it. Cisco didn't get into that and say, well, let's come up with a better web server. We're like, there's no S on the end of HTTP. We need the secure protocols. That's what we're trying to build the consortium up so that we can interject the things that we've learned. What would happen today if you want to do telephony right now? Just say telephony was going from the old POT systems that we had to the internet protocols. A lot of people would be saying, oh, let's just do it over HTTP 1.1. That's not going to work. Right? So we have this inflection point now where we have a chance to change the protocols and communicate with the other people in the consortium to establish something that's going to work well for these agents instead of hacking it along and then we're like, oh geez, how do we get Hypershield in there? How do we get ICE? How do we get the different applications in? So that's what we're trying to do. We're trying to get a consortium to work on this problem so that we can help with the Internet of Agents.
Yeah, and even just give a little more context, like the previous slide that we showed, we had 1 agent over here to 3. What does that look like when we scale to 1,000? And now, this agent wants to stream updates to another agent, or we want to share media content. The current protocols that we have weren't necessarily designed for that type of interactions. And that's what we're trying to solve here.
Yeah. So one of the things that they've done, and this is just to organize and show the flow, is Agency says, you're going to find agents, you're going to compose them together, You're going to deploy them and you're going to evaluate what happens on them and observe them, and you're going to keep doing that in a loop. So the idea is you might find an agent that does some task and then say, oh, I'm going to onboard that into the company, I'm going to use that as an application, I'm going to deploy it, and you're going to keep doing that. And we might do that for a little while until we get comfortable with systems of agents. So we see that as the workflow today, and we're like, okay, let's go through the workflow and try to see what we can do. We have different partners, and you can take a look at them on the slides, that have signed up for different areas. And these are some of the bigger names in AI today. So they're all coming in and giving us the advice and trying to work together to set up this problem, to solve these problems. This is the architecture, and if you look at it, it's really the working groups that we have inside the collective. There are groups of people that are working on identity, a catalog, a directory, semantic transports, workflow, observability, and security. And I'll go over briefly what they are. But we found that these are the problems that you need to solve in order to have multiple agents talking to each other and working on a problem. The agents are almost getting onboarded like employees getting onboarded onto the network, less so than applications, but they're still applications. They need to be signed. So what we're working on is identity. If I have an agent or an LLM, it has to have an ID. It has to have an ID that's signed, and what's the authority? Where are the certificates for that? I have to identify that specific agent. I need a catalog. A catalog of agents is how many agents are able to interact with Salesforce? Well, there might be 5 of those. I'm going to grab this one. Well, the one that I grabbed has an identity. Does it actually implement what we said it implemented from the catalog? So the catalog description needs to be signed as well, so I know what its capabilities are. Then I need a directory, and we'll talk more about that. That's one of the ones that we've released. A directory where, when I want to go and find agents that are in another company like Salesforce, if I connect to it, I want to see all the agents that they have there, but I might have agents in another company. I want to see a full directory of them and say, where are they? I don't want to have to go to each and every one and say, oh, I got to sign in and then find it. I would love to see all of them together. So that's one of the things that we're talking about.
And I would say, just quickly on these 3 too, this is almost like a DNS type of thing, but for agents, right? So we want to know the identity, but we need to know what does it actually do. If I look up in a DNS and I just get an IP address, well, if I'm going to use that agent in my workflow, I want to know what it does, and I want to verify that that's who it is. So these 3 are kind of like looking at what would a DNS system look like in an agentic internet.
Putting up the skills. I want an agent that can do this, and then you can find it. Now, what's been going on now, if you've been trying to build agents, is everybody's in the middle of this one, us included. We're coming up with the semantics, syntax, and a transport for the agents. So this is where you hear MCP is the protocol that we're using to talk to the tools. A2A from Google is how we talk to an agent. We came up with ACP, Agent Connect Protocol, and IBM came with an Agent Communication Protocol, which was also ACP. There's like 13 of them now, of these semantic protocols, but the transports are roughly the same. It's HTTP1 or it's gRPC, and we're looking at that going like, guys, don't define the transport all the way down the OSI stack by the language that you're speaking at the top. Figure out the language and separate the transport, because please God, we have to help you to optimize the traffic, to shield it with Hypershield, to onboard it, things like that.
Yeah, and maybe just to add on quickly too, the semantics, what are we trying to do here? We're trying to kind of replace the API model with now something that works for an agent. An API making a GET request, a POST request, but when your agents speak a natural language, what is something that flows a little easier for them to understand and be able to collaborate with more power than a typical API. And then transport, we're also going to be handling streaming back and forth bidirectional flows. So what makes sense again for this natural language bidirectional agentic communication?
Yeah, and then workflow. You want to talk about the workflow?
Yeah, so workflow is essentially how do we serve these agents? How do we run them, deploy them, and kind of execute through the life cycle of an agentic flow?
So like if you're running something that does point of sale or something, and saying I want to buy something, then I need to get a human to approve it, then I need another agent to audit it and actually pay. Those might be different agents and they have to go down a certain step. So the typical workflow that you might see in microservices, you're going to want it, that same kind of flow, but now instead of APIs, you're dealing with agentic communication. And then observability and like open telemetry, please, from top to bottom, all the way through. The model should be going, inside the LLMs, there's open LLMetry, which is hard to say, but it's open LLMetry. And inside the model, we can see what the reasoning is, but if you're an agent and you spoke to that agent, you need to tell us how you reason, but I also need to know what you were talking about, right? So that's the kind of things that we want to make sure is standard. And we see that flow, and that flow should come back down into like 1,000 eyes flow, so we can see where the path took along the way. That's the kind of thing we want to help out with.
And why do we need that like right now? Why are IT teams wanting that? Well, every engineer is like, give me an API key. I want an open API key. And they're all, crewing charge, everyone's running these agents, and we don't really have observability, but we get to a point where everything is being tracked, observability across agents. That's what we need with a standardized observability.
Yeah, and the other thing with observability is that most of the time, the agents, when they operate, it's not as deterministic as it used to be. It used to be we validated a system, it does exactly this, and I deploy it, and I know it will not do that. And you're like, well, it might not really do that. So I better have a good audit log and have something else looking at that audit log to see did that work or not, right? So those are the things that we're going to do. And then security. Security has to do with like identity and all that, right? We have to say, are you the agent that I wanted to talk to? But it might be role-based access. So if I give you a task as an agent, go do something, you might get higher security credentials or access to information than you normally would have because you're doing my task. So this is kind of like the root user getting root for a while and then not. Like we have to work that out. The applications can't just say, oh well, that's the only permission you get because it's not a static system. So there has to be a task flow in order to do that. And if I ask a question, if I ask any kind of a chatbot and I say at Cisco, I say, should we buy Acme Company? Well, I don't, that information getting leaked in itself is wrong, so there's role-based access. If I'm part of the acquisitions team, I can ask that question, I'll get a very different response than if I'm somebody in HR, right? So those roles and the answers have to be worked out, okay? So, if there's anything you take away, keep this one here, because that's sort of a guide through what's coming up, and you can ask the questions. What's the security? What's the observability? If these things aren't being taken care of, then you know you've got a system that's probably not going to be working in a full production system. Okay, so there's a lot of work here because the protocols are fun, right? So everybody's going after these. So there's maturity in here. A2A is from Google, ACP is from us. MCP is coming from Anthropic, and the transport protocols will show you what we did. Directory in the catalog, we put out a proposal for that, and it just went out like 2 days ago, so we're going to see where we're at on those. The workflow is not that mature. Observability, we've done it end to end, but there's no standard for it yet. And security is just always there. We're always trying to secure it. So I'd say most of the people are working in here and dabbling in here right now.
Out of the middle, like MCP, as opposed to the Cisco, Google individual. MCP would be like the BGP of the routing protocol.
Yeah, MCP is not like a routing. Okay, so the question was, is this like MCP coming out like as a protocol like BGP? MCP is really MCP to me is more like FTP, right? It's like there's a server over there, and I have an easy way to go get files, right? So there's an FTP server, I can get to it. If I want to get to services, there's an easy way to get to those services, right? So if I had to give an analogy, it's more like FTP, right? Like it's a standard way to talk to the different files. So this MCP is a standard way to talk to different services and applications.
Let me try to answer too.
So my question is, MCP is becoming the leader?
For tool calling, we'll show you that in an example. Yeah, we'll show you that.
Right now, I think it is definitely the top, but it is somewhat specific to giving context to an LLM, so being able to connect to external systems. But we think that as there's more agent-to-agent communication, that there might be something else that will also gain popularity, and MCP will be the agent-to-data kind of protocol.
Okay, so we're going to show you a reference application. So one thing that we did is we were like, we kept seeing examples, and everybody was like coming up with like these toy examples of like, I did a travel agent, I did this, or I booked a reservation. It was like not showing something at scale. So we said, let's take one of the hardest systems that we know how to build, and that's like a worldwide supply chain. And let's give that as a sample application. So we have, what we're putting out in the open source is called Coffee Agency. And it's going to be a fictitious coffee company that is sourcing coffee from multiple locations around the world and then doing bidding and calling for them, and then we're going to take it into shipping and tracking orders, and then all the way down to retail. We think if we get an example like that and we grow that example, you all will be able to see what a system looks like as this matures. So we're picking an application that is going to grow as the agent community grows, and we want to show you those. And we're going to have two setups in the open source repository. Corto, a small one, and Lungo, a long one. The small one is just two agents talking to each other. That's it. If you guys just want to see like, hey, how does this work with two agents? Let me grab the short one. It's two agents working together. The Lungo one, we envision having everything that I showed in there. Identity, directory, services, security, observability. We're going to, as it grows, we're going to keep adding to it. So it's more like follow us and stay tuned, okay?
Yeah, and even in the simple one, I would say there's nuance to communication too. How are we talking?
Yeah. So Cody's going to show you the demo application.
All right, so in this one, we're just going to ask a question. We have kind of a supervisor pattern. We have a top-level agent here, and it's going to talk to a bottom-level agent here. But the key thing that we've done in this demo is that we've separated out the protocol layer from the transport layer. So no one else has really been doing this so far. So we've taken 808 from Google. Google has released 808, their agent protocol, but we're actually going to use our protocol, our transport, called SLIM, which is basically a gRPC-based, low-latency, bidirectional transport for agents. And so what we're doing here in this simple case, as John mentioned, is just being able to get agent communication using 808 over our transport. And you could swap these in and out with this design.
Yeah, so the idea is SLIM is the transport protocol that's coming from agency, but really what we did is we wrapped gRPC and put observability, and we're going to put in some optimization and PubSub in there, and we call that SLIM so that we have a placeholder where we can inject. If we see that the communication needs optimization or separate channels, we can do it. But what the industry is doing right now is they're like, all right, just do HTTP 1 all the way down or gRPC 1 all the way down. We're like, excuse me, we're like, we need a holder so that we can innovate in that, instead of us going back and saying, hey, gRPC doesn't work, and we got to go and we have to go and change it. We're like, let's call a new protocol now, and we'll start to add to it and use the best of it. But you don't have to use SLIM. There's other things that people use for communication patterns. People use MQTT, they use NATS, they use TIBCO, they use Kafka. So if you guys are all doing that, you can still do A to A over, insert your own transport. Right? So what we'll do in the open source is say, during this period of change, we'll help you try it out and try it on systems that you might already have. So if you have a whole Kafka bus set up already, you can put agents in there and have them work over Kafka and not have to worry about like, oh my God, I'm tied to this one protocol. And you could try that out. Now, going to production, let's see, but I have some time for that. Okay?
Yeah, and that comes directly from Cisco's kind of open interoperable, right? We want to be able to handle all different transports and protocols, unlike maybe some of the other players who just want to use their stuff.
Okay, so we'll show you now the Corto one. This is the more complicated one that's going to grow. This is the simple version of it yet, and we're hoping that this will become a full-fledged system as we add more and more to it.
Yeah, so what's interesting about this one is we're sending it through SLIM as well, but now we're actually doing a PubSub broadcast to multiple agents. So again, no one else is really doing this yet. Everyone is doing a point-to-point communication from one agent to another agent, 808 or MCP to each other. In this case, because we're able to separate the protocol layer from the transport, we're doing a broadcast while using the same protocols that everyone's used to, broadcasting it down to these agents, asking, who has coffee that's available? All of these agents are going to respond back to the supervisor, and it can then decide who do I want to initiate orders with and go in that more traditional point-to-point manner.
So the idea there is that we get the pattern of communication down. Broadcast out, which one of you can service the coffee? You said yes, okay, now I can do point-to-point with you, right? So maybe I use PubSub to broadcast, but maybe I'll be doing gRPC or HTTP directly. So you get the choice, and we're giving the developers a choice, and we'll see what happens as people start to build these agentic applications. Make sense? So by abstracting that out, we're able to try these things out, and that's Cisco trying to be open and say, hey, we'll figure it out, but please God, make the transport separate. So that's the code for it. Yes, go ahead. Okay. All right, so the question was, are you faking it out by using RabbitMQ underneath it? We really do it. We've done it with NATs. We've done it with MQTT. In this one, we're using Slim, which was developed by our team.
Cisco Outshift.
That Cisco did. It's based on gRPC, so we implemented PubSub over gRPC. It's like a different one parallel to it, but that's what we did. It's separate to it.
It may have something similar, so it uses HTTP1.
Yeah.
So do they have some PubSub model like this?
Okay.
No.
So the question is, I have to repeat it for that. The question is, does 808 have a PubSub mechanism? No. They do HTTP 1.0 up until what, 15 minutes ago, literally, they just said they were going to do it over gRPC. So they just released it today.
But no PubSub.
But no PubSub. So, you know, there's still no.
The case where a supervisor agent would want to talk to the agents.
I'm not, the question is, oh, but they haven't thought about it, they haven't envisioned it yet. Everybody's thinking about it, but they're going one at a time. They're saying, hey, let's just do point to point on that. Cisco, I always talk about this in my talks, it's pets versus cattle. Everybody's got a pet. I got my pet agent and I'm trying to deploy it. And we're like, Cisco, we're like, yeah, talk to me when you have 20,000 of these, you know? Like, this is like when we did wireless. Wow, I used an AP to do wireless. Talk to me when you've got 20,000 of them in a building. That's what Cisco's good at. So we're automatically going to that. Are they thinking about it? Sure, probably not as much as we do, because that's just, we think big numbers. They're thinking one.
We've talked to them about maybe you know, bringing some of this into what they're doing.
Yeah.
So you can see right here when we're creating a client for 808, see right here, we're going to return an 808 client, which uses JSON RPC HTTP, right? But we override the send method for 808. So the 808 agent thinks that it's using its HTTP method, but it's actually using our transport. That enables us to use PubSub underneath if we want to. So that's what we were doing in that example, where it is the 808 client, but it's actually us doing the PubSub underneath.
And we're gonna donate that back or talk to them and say, hey, have you done that? And we've shown this to the 808 team, and they've been like, yeah, okay, let's talk about it. And we'll go back with the consortium and say, hey, everybody, let's go do this. Let's go do PubSub, let's push it out, right? Because we could do a pull request and just say, hey, go in there, but we want to go in with some cache and say, look, we've tried it, and that's why we got the reference application to give to you all. It's like, try this out. Try this on your Kafka buses. Try this on your systems, your test systems, and see how that's working out. How would this fit in your production systems? And we'll take that back to the consortiums, to MCP, to A2A, and then say, this is the reference architecture that people should be using based on your all feedback. That's what we're trying to do.
Yeah, and the benefit, like, Google obviously isn't going to want to support other protocols if they don't have to, right? But as Cisco, we want to create a factory method that says, yes, we want to ask for 808 and we want this transport, but it doesn't have to be 808. It could be, you know, MCP. It could be another transport. So we can be a little more interoperable and open versus what Google is probably going to be, you know, they have their roadmap for 808.
Yeah. So it's coming down to us trying to influence, you know, coming from the point of view of multiple open internet of agents versus, you know, a specific cloud of agents. You know, keep running. Well, this will all work on just only in AWS or only in Google Cloud. We want it to be open, right? Because these things are going to start to look like microservices at some point. Okay. Awesome. Any other questions on that? Is that hitting to what you guys are doing? Yeah. So, as we saw before, people got these pets. Like, I got my agent working in LangChain. I got my agent working with MCP, and oh, I've used MCP to make two agents to go together. And we're like, okay, good. But when they want to talk this way, you're going to need more communication. When you want to do coordination in larger systems, you're going to have different protocols and a ton of different concerns. Like, think about that Brazil farm coming online. If that Brazil farm came in, I need to certify it. I need to get the cert. I need to get it from a directory. I need to know that it's trusted. So there's onboarding and offboarding of all these. So that's another area that we're looking at. Okay. So this came from LangGraph. if you're ever, you could, this one, if you get from the material, is when to use MCP and when to use an agent protocol. And it's like, if you're in control of all your data, and you're in control of the server that you're speaking to, you can use MCP or something like that. But the second you are not in control of it, where things are coming and going, or you're talking to another third party, that's where you're going to need some sort of an agent protocol, because you're collaborating and you're not in control of the data. But if you're all in control of all the agents, you can just build them as one system. Anybody who's doing any kind of software, it's kind of like having all your classes and your objects inside one big VM, and then you're like, oh no, wait, they're distributed objects, right? That's really what's going on, is this rebirth of distributed computing, but instead of being software objects, they're now AI objects, they're agents, okay? All right. And this is talking about this, we're just showing you as a reference, saying that, okay, here's the stack, and then here's A2A, what they're doing on top. And what we're saying is, in agency, we're saying all this stuff at the top from gRPC down, that's the part that we're trying to encapsulate and turn into one communication protocol so that we can mix and match and change them. Okay. Okay. This one is for your reference. If you need to, somebody's telling you like, okay, what's the difference between model context protocol, A2A, and what we're doing? It's a quick reference that we got. Okay. All right. Any questions on that? That was a lot. Are there any other organizations? ADK, oh, the Agent Developer Kit by Google. Is the Agent Developer Kit like this? Right now, the Agent Developer Kit just has, it's all set for A2A, right? Yeah.
Yeah, I mean, we're trying to just support, multiple protocols and transports. I think that's the main difference. Like, we have a larger collective that we'll show in a second that's bringing in, companies that are building different parts in the stack. So I think we are maybe looking at a larger scope with a larger open collective.
Yeah. Okay. That was that center part. Like, we went a lot in that center part, because see, everybody's going nuts trying to figure out the protocols and the transport, so we're talking about that. I think a gentleman over here asked about, like, what's the next thing that people are working on. The directory seems to be the next thing that we're working on. So we'll show you what we thought is a good way of doing directories. We don't know if it's going to work that way or not, but this is one way of doing it. Maybe it might be more MCP servers. We don't know how it's going to come out, but this is what we're suggesting for an implementation. But I just want to leave it, see if there's any other questions on like protocols or things before we change. Okay, let's go into directory. Okay, so this directory is set up at, we'll show you the live one. It's at hub.agentcy.org, and this is where you would put in your cards that describe the agents. So for our coffee agency, I want to find all of the agents that were in that coffee simulator, and I could find them in this directory. The idea for the directory is that it's more like a DNS than a directory in your company. So it might have multiple nodes. There might be, like, if you're a company and you have 5 agents that you're making public, and one of them is a coffee agency, it would show up in the search here. If you had some in your directory, I could merge these 2 directories when I search. So it's not like I have to go here and search, then come back and then go there and search. It's like, let's search across all of them. That's what we think it might work out. We'll see. I mean, you could very easily just keep doing that, but we're like, we have an opportunity here. We're like, let's try something cool, and maybe we could search across all of them and pick the one that you want, especially if we sign these things and we have good security and identity on those. So that's what we're thinking. So the idea here is you would come in here and you would look for agents that you have, that you can talk to from the directories that you're allowed to talk to, and you could look at those directories and search across them. They don't have to be hosted in your company. They could be anywhere else, okay? So the idea is built on distributed hash sets. So distributed hash tables mean that what happens is you can have an agent directory service running in multiple locations, and then you could have a client that can query across them. So it's distributed hash tables, basically. We would have a directory service in one company, another company, and we would be able to search across them. So what we did is we compiled up and built. Oh, you don't want to do that. So we compiled up this directory service that we can put in there. And the idea then is, in your corporation, you might have private, protected, or public agents. There might be some out there that are in the public that people are just putting there, like Hugging Face or something. And then some supplier like Salesforce or somebody might be giving you these that are public. The second you say that those agents are public, I want to be able to search across those. whether or not it's in my domain or not. And then the idea there is that when I search, I would see all of those as one big space and not one individual one. So that's the thing that we proposed, and we stood up a hub and directory service and said, let's try it, right, and see if this works. Are we tied to this? No. We want to get feedback from the reference application and just keep working with all the different communities, users, the working groups, and see if this resonates and if this works. Right?
Do you mind going back just to the implementation side? I want to give just a little insider on the architecture. Yeah, so some of the motivations here, this seems fairly complex for like a database, right? So what are we really trying to do here? Well, this is, if you think of a DNS that's scaled and there's millions of agents running around, what we're thinking is distributing these in a way that you might distribute in a blockchain or something. So each of these is kind of like an Ethereum node in a blockchain, essentially. So this is the same library that Ethereum uses, and they're actually kind of distributing and announcing kind of who's storing what to each other in a peer-to-peer manner. So the underlying networking is pretty interesting and is the same kind of approach that like Ethereum and IPFS is using.
Yeah. So that's what we pitched and we put out. We said, okay, let's try it this way, see if directory services work. So the idea is, when you're building that coffee agency, you could say, oh, here's a directory of agents. I can find the one from the directory. You could use the sample code that we put in there to stitch them together, and you could very quickly put together an ensemble of agents that can then work to a task and try to be able to do that pretty quickly. So we're trying to get the developer experience to be just find an agent, get another agent, pick a transport, connect them, and then the agents will start to communicate with not a lot of code in there. We don't want to make it very code heavy on it. There will always be coding, but we want to make it easier for people to understand, debug, and things like that. Okay? So that's the directory service, and then we'll give the demo of the actual live one.
Yeah, so this is what we showed before, so you can essentially search for some agents. We'll search for the ones that we did. So you can see the coffee agents that we have here, and then you can also see a drop down of the skills. So you can search for the different type of skills that you're looking for from those agents.
Yeah, delete the coffee one, just grab a skill, see if we get any. Like, clear the search, and then just do that, yeah. Yeah, so that's finding all the ones that can perform that skill. So you can say, oh, those are the ones I have to choose from, and those are the ones that you have access to. And then you can pick one of those, and then you'll get the access information, the card, and then that's how you can then connect to it in the protocol.
Yeah.
So the idea is to be able to find them, find the agent, get the information you need from the agent, connect them up, and then build a system of connected agents in order to achieve some task. There's a whole other world of deployment of this and everything. We're not even going into that, but we have to get to the point where we can build these things easily, so that deployment of these things is as easy as if it is as a microservice, right? So taking something and deploying it along those lines is the way we want to work on it. Okay. Okay. So we'll let you try these things out yourself on how to get involved in this. Go to github.com. Just go to our repo and agency. You can join standards from the tooling. You can come here and contribute. You can adopt or try it out, and try out the examples in the coffee agency. You can take a look at the hub. You can look at our operating model, so that you can see how, if your company wants to join up or anything like that, we can set up how you can join the consortium and contribute to it. But just being users of it is what we need. If people try it out, and then you can see the differences of the different protocols. We're thinking it's a good playground and sandbox for everybody to start to work with as this whole thing starts to evolve. Okay. Okay. We have a bunch of videos out there. There's blogs. You can take a look at Outshift as well. We have the Internet of Agents. There's a bunch of videos and blogs out there. Every time something comes out, we're going to try to talk about it as much as we can out in the open and say, oh, we've tried this, we've tried that. So as we start to experiment with this, we're going to start putting more and more information out there so you can see what we've done. Okay, so multiple agents, multi-agents, the agency collective. Come away with you working on a coffee reference application and trying it out. Take a look at the components and then try these things out yourself. And then, complete your session evaluations and stuff. But if you have questions, we're here for questions. Anything else? Nope. All right, I hope that helped. It's a long journey for getting this stuff to the point where it's going to be prolific everywhere, and it's changing a lot. So our hope is that you join up in here, and then as it changes, you guys can come along and give us the feedback that we need to make it accessible for you all. Okay? Great. Okay, thank you very much.
Thank you, everyone.